Let's see one more example on total probability. Assume that we have two bags, bag A and bag B, and say there are two green balls here and three red balls, and here there are three red balls and two green balls. Okay, and now the experiment is like this. We'll first draw a ball from bag A, and we add it into bag B. That ball can be either green or that can be red. And next we draw one ball from blue. Now we want to see what is the probability that the ball which we draw is red. Okay, so try to understand the question again. We have two bags. We'll draw a ball from A and we'll add it to B, and after adding it we'll draw one ball from B. Now what is the probability that the ball is red? That is what we wanted. Now again, this you can do it using total probability. So in exam you can directly do it directly by writing the formula, and then you can do it, but here I'll go slowly. All these examples, even though you understood it, I'll go a bit slow and explain you everything, but in exam you can do it fast, but here I'll go slowly. Okay, now what is the sample space? Now this experiment actually contains two things. First thing is drawing a ball from here and then drawing a ball from there. So now when you draw a ball from bag A, it can be either green ball or red ball. Therefore now initially we might get red ball initially from the bag A, and then we might get a red ball from bag B, which means first ball is red and second ball is red. That case is perfectly possible. Similarly, first ball can be red and second ball can be green, right? Or first ball can be green and second ball can be red, or first ball can be green and second ball can be green. These are the four possibilities we have. Now what is that we wanted? We want the probability or total probability that second ball is actually red. This is what we wanted. Now again, in order to solve it, based on what happens to the first ball that is drawn, we can divide the entire sample space into two parts, right? So this part and this part, both are mutually exclusive, and we can apply the formula like this. So what is it? Now we have two events, E1 and E2, and the event that we require is actually spread across these two events. This is E1, let's say this is E2, and let's say this is A. Now earlier with the total probability, we have seen that probability of A happening is equal to probability of E1 intersection A plus probability of E2 intersection A. Now how did I write it? Because they are mutually exclusive events. Got it? And then what about this probability? That depends on whether E1 and A are dependent or independent. In case if they are dependent, we are going to use conditional probability. In this case, can you just tell me, are they dependent or independent? Which means the probability of getting a red ball here depends on what is the event that happened here. In case if the event that happened here is, if we get a green ball, then the probability will be something. In case if it is a red ball, then the probability will be something. Therefore these two events are dependent, which means the probability of getting a red ball here depends on what happened, or which ball we have drawn from bag A. Therefore they are actually dependent events, and so when you are doing this, we should use the conditional probability, right? Which means we should use the formula like this: probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Got it? So this is how I am going to get the total probability here, right? And now coming to this example, let's do this. Now probability of getting a red ball second time is equal to probability of getting a green ball first time into probability of getting a red ball second time, given that we got a green ball first time. Now why are they dependent? Because once we pick green ball from here and add from there, the probability of getting a red ball is going to change, and it is going to depend on green ball first, right? plus probability of getting a red ball first into probability of getting a red ball second time, given that first time we have drawn the red ball. Now let's see this. What about probability of G1, probability of getting green ball first? That depends on only this one, right? So which is nothing but 2 green balls are there, totally 5 balls are there, therefore 2 by 5. That is the probability of getting a green ball. What is the probability of getting a red ball? Given that green ball has drawn, now once we have drawn green ball here, then the green ball will be added here. Therefore, there will be 3 green balls and 3 red balls. So totally 6 balls will be there. Out of which, what is the probability of getting a red ball? 3 by 6. Are you getting this? Totally 6 balls will be there because one more ball is added and that new ball is green ball. Therefore, number of red balls doesn't change. That is by 3 divided by total number of balls now will be 6. Got it? Plus, what is the probability of getting a red ball? Probability of getting a red ball in the from A is equal to 3 by 5 multiplied with what is the probability of getting a red ball in the second try, given that we have got a red ball from the first try. Now since we got a red ball from here, when we add it, then we are going to get 4 red balls and 2 green balls, which means totally 6 balls are there, out of which 4 are red. Therefore it is going to be 4 by 6. This is the total probability of getting a red ball. Got it? So in exam you can directly write it and then you can directly write this one and easily solve it, but here I wanted to go slow explaining you everything. That is why I am going bit slowly. Okay, so the intention of explaining this is just to give you a much clearer idea about how the concept is working. So anyway, this question can be answered using total probability this way. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.